So the most common question that you might get regarding the memory is what is the difference between a stack and a heap memory? So the whole idea is that your, let's say, program has threads. You've got a main thread whenever you start a new process, and the thread has an associated stack memory. The stack memory is used to track where are you exactly in the functions and what local variables are there. The idea is that whenever you exit a certain function, you actually deallocate all the local variables that are in scope of this function, and also you remove the stack, let's say, trace or data regarding this function pointer that you're in, so that you know exactly where you are at right now. So later you just go back to the main and actually close the process in the main thread. Each thread has its own stack memory. It's pretty limited and its size depends on the operating system you're using. And the whole idea is just to track whatever you're doing with the very fast stack memory where you exactly pretty much know where's the top and what exactly to allocate. The idea is to use just some simple and trivial types on that and just to hold the functions. You can also have a certain thing called Stack Overflow. There's also the very popular name of the site called Stack Overflow. That pretty much says that you want to allocate more stack memory than you can actually allocate, be it from creating too many variables or going through too many functions. If you reach that point in your program, you might reconsider changing the architecture or the idea. The heap memory, on the other way, is pretty much the whole memory that your computer can actually provide. So let's say that you want now to allocate 5 megabytes. In C++, you might just use a new operator, and the whole idea is that you pretty much allocate whatever the data you have that has a 5 megabytes of size, and the operating system provides you with a certain amount of pages to your program. So the thing is, you are not actually using the memory mapped from your actual random access memory, but the operating system creates a certain, let's say, abstraction that is a virtual memory, so that the first thing is whatever you allocate will be actually, let's say, mapped to your process with a virtual memory, so that it will be easier for a system to take care of the memory. And the another thing is you don't actually allocate like up to a 1 byte of a memory, you allocate actually pages. So imagine that you want to allocate 5 megabytes, but you have a page size of 2 meg. So you have 2 megabyte pages. You need to allocate 3 pages, for example, just to allocate those 5 megs. Of course, if there's no free memory from before, because it might be even 2 pages or whatever. And the size of the page can be actually changed. Depending on the operating system in Linux, it's very easy. You just go to the variable in the operating system and change its value. Imagine that you can have even a page size of 1 gigabyte, and you just allocate one big page whenever you start the process, and then allocate maybe one more or two, like whatever, depending on what your program actually needs. The idea is that actually there's another lookup regarding the pages that allows you to remove some cache misses and find the actual page that you're looking on instantly. So the idea is that the heap memory is the whole memory that you can access in your random access memory. Of course, that is not used, that you can still allocate on. And also you need to have a page size that allows you to do that, so that you can actually allocate your memory that you want to allocate. So the differences are pretty simple. Each thread has its own stack. The stack is very limited, the stack is very fast, and it's used only to track in what function you are in and what local variables are you using right now, just to allocate them later very easily. And it's also used for debugging. Yeah, you can easily debug. There's those stack traces and whatnot to check where the program crashed on which, let's say, method or on which variables. And also there's this heap, and heap is pretty much your whole memory that you can use. And also you can fail the allocation because there's not enough memory. And pretty much depending on the implementation, you will either get a null pointer or some throw with exception or whatever it is. But pretty much that's the whole idea regarding that. Yeah, and that will be the correct answer regarding the stack against heap differences. Thank you for watching.